Hi folks, Don Knotts here, and this is analysis of variance, which is called the ANOVA test. Okay, so ANOVA is used to compare means for more than two populations. So if you're comparing proportions, that would be the chi-square, but when you're comparing means, it's ANOVA. So it's more efficient than performing multiple t-tests. So your conditions, the data has to come from independent SRSs. Each population must have a normal distribution with an unknown mean, and each population must have the same standard deviation, okay, with unknown means. So to ensure this, the largest sample standard deviation cannot deviate more than twice the smallest. So what you do is you take the biggest standard deviation, divide that by the smallest, and just make sure it's less than 2. Okay, and you get your standard deviations from your graphing calculator right there. Okay, there's long formulas in the book. I'm going to show you using the calculator. If you want to see the long formulas, then I would take a look at what some students did of mine, past students. Uh, they did the ANOVA video and they did the long way, and I'm just going to show you the short way here. Okay, so the ANOVA hypothesis is that all the means are equal, and the alternative is that none of them all are equal. At least one of them is different right here. So here's an example. Experimenters placed 6 boards, each of 4 colors, at random locations in a field of oats, and measured the number of cereal leaf beetles that were trapped. We want to see which color attracts the insects the best. So here's the data. So board colors, a blue board's on 6 boards. They got 16, and then 11, then 20, then 21, 14, and then 7. Okay, and then they did green, and that was the numbers for green. Then they did white. That was the numbers for white. And finally, there's the numbers for yellow right there. Okay, so what we're going to do is check the conditions right here. So the data is gathered from a random samples right there, and then we don't know if it's normal or not. So always, you guys, make a stem plot, you guys, a stem plot of your data, particularly if it's small. Your AP readers want to see a stem plot, and this one looks, reasonably normal. This one looks reasonably normal. There's not, if there's skewness, it's not very skewed, you guys, particularly since the data is only 6. They're pretty good. This one's same thing, pretty normal. This one's definitely pretty normal right there. So say something. Each plot is relatively normal, especially with a small number like 6 right there. Okay, so check that the largest sample standard deviation is less than twice the smallest. So what I would do, you guys, is I would plug these numbers right here into your calculator. List 1, list 2, list 3, list 4. All right, and then you can calculate do a one variable stat, you guys, and then you can get these numbers right here. Okay, so here's the sample standard deviations right here. Once you do that, and then take the largest one, which is this guy, divide it by the smallest one, which is this guy, and just make sure it's less than 2. Okay, and as long as that is good, then the conditions are met, and we can proceed with your ANOVA test. Okay, so again, there's a long formula, so put those in your graphing calculator, and then next go to stat, and then scroll over to test, and way down at the bottom, or just click one click up, and it'll go to ANOVA, you guys. And then so ANOVA, then do list 1, comma list 2, comma list 3, comma list 4, and then hit enter, and you're going to get numbers like this. Okay, always for your AP reader, they want you to write down your F statistic. Here's my p-value, 6.8, and then it says e to the -9. That means this decimal goes 9 places that way. So there's 8 zeros, and then so 0.0008 of them, and then 68 at the end right there, which is virtually little, you guys, very, very little. So p is very small. It's virtually 0 right there. So so we can reject your null hypotheses about all the means are the same, and definitely the means aren't the same. Okay, at attracting beetles. So there's strong evidence that there's a difference among the colors, and I can see that the evidence shows that yellow seems to attract the most bugs right there. Okay. All right, so and then you can see the video on ANOVA that one of my students did. Should be right around this one right here. And if you're in my class, I would assign that for your homework. Take care.